Question number 3. If 50 kg ammonia and 100 kg oxygen are fed to a batch reactor, determine limiting reactant of the process, percentage of excess reactant, extent of reaction, and mass of NO nitric oxide produced in kilogram if reaction proceeds to completion. As I mentioned in previous video, in order to solve mass balance with reactive process, it has to be performed in terms of mole, not in terms of mass. Okay, in these questions, you are given your feed in terms of mass. So the first thing before you do any calculation, you have to change the mass given into mole, number of mole. So let's do the change for these two reactants first. Okay, first of all, so we know we have, let's find number of mole NH3. Now first, so we know mass of ammonia is 50 kg given, right? And for oxygen is 100 kg. So let's find the number of mole for ammonia first. So we know we have, so in order to convert this mass to mole, what you have to do is you use the basis given in terms of mass times with your, divide with your molecular weight. Okay, so we have 50 kg of NH3 divide with NH3 molecular weight. So the number of mole that correspond to 50 kg of NH3 is actually 2.94 kmol of NH3. So now let's find number of mole for O2. So O2 given in terms of mass is 100 kg O2. So we divide with its molecular weight. So 3.125 kmol of O2 corresponds to 100 kg of O2 given in terms of mass. So this is 3.125 kmol. Okay, now once we already get number of mole for ammonia and number of mole of O2 from the conversion just now, now let's proceed to find the limiting reactant. So remember from the previous video how we do to find the limiting reactant. So we have to compare the ratio of stoichiometric with the ratio of actual compound. Okay. So in this process, I will choose NH3 as my numerator, and O2 as my denominator. Okay, stoichiometrically, let's see how much is actually the ratio between these two compounds. So stoichiometrically, NH4 is 4, O2 is 5, so we'll get 0.8. But you know your actual, now you know this is your actual amount that goes into the process. Actual, so we take this one from ammonia, divide with O2, so 3.125 kmol. So what do we get? We get 0.94. You see, now your actual ratio is higher than your stoichiometric. When this happens, when stoic ratio lower than actual ratio, therefore it means numerator is excess reactant. So in this case, your numerator is NH3, excess reactant. Therefore, O2 is limiting reactant for this process. So the process will proceed according to O2 in this process. Okay? So, but the questions, after finding the limiting reactant, the question wants us to find the percentage of excess. Okay, you already get your limiting reactant, but now we have to find the percentage of excess. Remember, O2 is our limiting, and NH3 in this case is our excess. So, to find percentage of excess, we have to use this equation. Percentage of excess equal to N feed minus N stoic divided by N stoic times 100, which in this case our excess is NH3. In order to find the N stoic for NH3, we have to use the basis of O2, which is our mole of O2 that used in the process is 3.125 kmol. Okay, let's find what would be the N stoic for NH3 if we react with 3.125 kmol of O2. We take, so in order to find the N stoic, we do this calculation. 3.125 kmol O2. Okay, we use the stoichiometric ratio that relates O2 to NH3. 5 kmol O2 we react with 4 kmol of NH3, then we'll get stoichiometrically number of mole of NH3 is 2.5 kmol NH3. If we only use 3.125 O2, the limiting reactant, we only requires 2.5 kmol of NH3, right? So if you have this much, you only require 2.5 kmol of NH3. Okay, get this? So now, how much is the actual feed of ammonia that goes into the process? 2.94. But how much actually we only require based on stoichiometry? 2.5 divided by 2.5 times by 100, then you'll get the percentage excess of ammonia equivalent to 17.6%. This is how you calculate percentage of excess in your reaction.